Hello everyone, welcome back to the Python and Pandas tutorial series. In this video, we will explore one of the most powerful features of object-oriented programming, inheritance. By the end of this video, we will learn everything about inheritance from basic to advanced concepts. So let us start. To define inheritance, inheritance allows one class to inherit attributes and methods from another class. So for example, if we have two classes, and here we are referring those as one is parent class and child class. Inheritance allows the child class to inherit attributes and methods from the parent class. Means if we have some attributes and methods in parent class, without rewriting those in child class, those will be available in the child class if we use the concept of inheritance. So this helps in code reusability and hierarchical structuring. So the syntax of inheritance in Python is we will be having two classes. So the parent class is similar to the class we have seen in earlier examples. So we will be writing a class with the keyword class and name of the class and the body of that class. It may have some methods and attributes, and we will write another class, child class, and the name of the child class will be followed by a parenthesis, and in that we will be giving the name of the parent class from which we want to use the attributes and methods. So that will be acting as the parent class, and you can have additional attributes and methods in child class. In Python, this parent class is also called as a base class or superclass. So whenever you hear the term parent class, base class or superclass, all are same. And similarly, the child class is termed as a derived class or subclass. So usually the combination of words we use are, if we say parent class, then we term the child class. And if we are using parent class as base class, then we say child class as derived class. And similarly, if we term parent class as superclass, then we term child class as subclass. Got it? And this subclass is actually inherits from parent class. And child class can use all non-private methods and attributes of the parent class. We will see some examples for that. Before going into some examples of inheritance, let us see how many types of inheritance does Python supports. So we have 5 types of inheritance in Python. Single inheritance, where a single class is inherited from one class is inherited from another class. Second is multiple inheritance, where a single child is having multiple parents. And multi-level inheritance is inheritance in multiple levels. Means B will be inherited from A and C will be inherited from B, like that. And we have hierarchical inheritance. So we will be having multiple child classes inherited from single parent. And finally we have hybrid inheritance. So this can be termed as the combination of any of above inheritance models. So you will be using the combination of multiple, multi-level and hierarchical inheritance. So let us see some examples of all of these inheritance types. Open your Visual Studio and create a new file called inheritance-demo.py. And in this, let us see how we achieve single inheritance in Python. So as we discussed what single inheritance is, one class inherits from another class. So we should be having two classes. Let us define those. Using the keyword class, we will write maybe parent itself. So in parent, let us write some function show and make sure you use the self parameter. And in this, we write some print statement to let it know like this is from parent class. So I am from parent class. And now let us create another class and name this as child. And how we inherit this from parent means using the name of the parent class in the parenthesis, right? So remember, I am just using the names as parent and child. It's not mandatory to use these names only. You can use based on your requirement. So for now, I don't do anything in this class. I will just pass. Got it? So if you see this, in this example, child class will get the method show from parent. Even we don't write the show method inside the child class, it will copy the code from the parent class. So it assumes, or it is equivalent to writing the show method in child class as well. Got it? Just to prove that, let us see by creating an object to child itself. So I am creating an object to child and calling c dot. See here you are seeing the method show, right? So even we don't declare the method show inside the child class, we are able to see this show because it is inherited from the parent class. If you have any doubt, just try creating another class maybe some sample, and just pass. I am not writing any code, and try to create an object for sample so that we will try to access show method, or we will see if it has access to show method. See, if we hit s dot, we are not seeing show because there is no relation between sample and parent. Got that? That is why we are not seeing show method here. But if we change this by adding the inheritance over here, means by saying sample is derived from parent, and if you see now s dot, see we got show method again now, right? So because now it is inherited from the parent class parent, that's why we are able to access parent class methods. So now C is the child class and C object. The object of child can access the members of parent. And if you run this, clear the console and Python space inheritance demo, you will see I am from child class. You are seeing the message which is actually written inside the show method from parent class. This is how we write single inheritance. And let us see how we write multiple inheritance. For now, I'll just comment this, and I will create maybe multiple inheritance. Assume like a child inherits some properties from mother and some properties from father. So let us take two classes. One is mother, and in this define a function maybe color, and make sure to add self attribute, and print, you can say some color over here, right? Color anything, right? So or mother's color. Got it? And similarly, you have an other class called father, and in this define another function maybe height, and provide self. In this write a statement, print maybe height is 6 feet. Okay, and now let us create an other class child, and we need to inherit child from both mother and father. How can we do that? Means just provide the list of parent classes comma separated. So mother comma father, and don't do anything just pass. Don't do anything in child for now. We don't need anything. So now if we create an object for child class, you can see child inherited all the properties and methods from mother as well as father. Check that by accessing the method c dot color and c dot height. So child class object is having access to the methods from mother as well as father, and if you access those by c dot color and c dot height, and if you run this you will see the same, right? See, color is from mother's color and height is from father. These are the properties actually child acquired from parents, so parent classes here. And now let us see the concept of multi-level inheritance. So I will comment out this. So multi-level inheritance means there might be, okay, now we have child and father, right? So there is grandfather, father and child. Let us see that concept. So let us create a class grandfather, and in this maybe we will define a function legacy and self. In this just we will add some print statements for now, but remember and understand these are the members of that class. Even if it is a single if it is a method with single line, it is a member of the class, and the child class is getting access to those members. Got that? So now we will write some statement, maybe grandfather's legacy. Got it? So this is how we have grandfather class, and let us add father class as well. And in this create another function, maybe wealth and self, and we say okay, father's wealth. And now if we create a child class, child, which is inherited, it is as simple as providing the name of sorry, we are discussing multi-level inheritance, right? So let the father class inherit from grandfather first, like this. And now we will be inheriting child from father. So father inherits grandfather's legacy and he has some wealth. Child inherits father so that he gets father's wealth as well as grandfather's legacy. And in this, do nothing. Got it? Just pass. And if you create an object for child class, and if you see c got legacy as well as wealth from father as well as grandfather, and you can access those two. Got it? So this is an example of using multi-level inheritance. See, we got grandfather's legacy from grandfather and father's legacy from father, whereas child just inherited from father, but father in turn inherited from grandfather. That is the reason child got both. See, comment out this and let us see another example for another type of inheritance we were discussing is hierarchical inheritance, right? I think we already seen that we wrote two different classes when we started, but let us repeat that again. So let us see the hierarchical inheritance. In this case, multiple child classes inherit from single parent. So the parent will be same, that parent has two kids, right? So we write class parent, and in this just define a function show itself, or instead of writing this just uncomment the single inheritance example, and we have written earlier and we just deleted that. So instead of c, name that as c1, so it is child 1 got inheritance from parent. And let us see, and this one also child 1 actually, so this is child 1, and create an other class child 2 also. Okay, so now parent 1 has two children, so now call or create an object for child 2 first, and you can see c2 gets show. Got it? So C1 and C2 both has access to parent now. So I am from parent class, I am from parent class. Both these are called by C1 and C2. So this is what hierarchical inheritance is. And at last we have hybrid inheritance. Means as I told earlier, it is combination of these. So let us see an example for this. Take a class A first, and in this define a method, maybe m1, and provide self, and in this just print method A. That's all. Sorry, this is method from A, right? And let us create an other class which inherit A. Okay, so write class B inherits A, and in this create an other method, maybe uh, def m2 self and print method from B. Got it? So we have two classes and we have single inheritance till now because we have A and B. A is inheriting from B. Now let us create an other class C. Got it? Class C, and let it inherit from A itself. Okay, so we have two children for A. Now create an other function inside method inside C and name this as 3 and just write here method from class C. And now create another class D. Got it? And now D inherits both B and C. Got it? So we are using multiple inheritance now. We have seen hierarchical inheritance as well as we are seeing multiple inheritance now. So we can define another function, maybe m4, and we write the same thing, and in this print method from D, like this. And let us create an object finally for D. Okay, and if you see this now, we can access all the methods m1, m2, m3, m4 because D inherited from B and C both, and B and C both are actually inheriting A. Got it? So you can call M1 and M2, M3, M4. I will change these to M4, M3, M2. And if you clear the console and run this again, you will see method from A, B, C, D got printed. So D got inheritance from all the above classes. Okay, this is how hybrid inheritance actually works. And sometimes we may need to call. Okay, I will comment out this, and now let us discuss one more concept called constructor of a class and the super in inheritance. Okay, so as we already know why we use constructor. Constructor is actually used to initialize the instance variables of a class, right? So whenever we write a class and we have some instance variable, we can write a constructor, and inside that we are actually assigning the instance variables with the values actually provided by user whenever they are creating an object. So whenever we use inheritance, we often call the parent class constructor also, and that can be achieved using one more thing called super in inheritance. Okay, so let us see an example for that. Here we will write a class again, or I will just copy that from here. Class parent child child1 we have, so I'll just have class parent and child for now. Okay, I will write class parent and class child, but instead of keeping the same thing in parent, we will define a constructor also. Okay, so how we define constructor? Using the init method. Got it? So this is how we will have constructor, and in parent take some instance variable called name and assign the self dot name with name. Okay, and instead of okay, we can keep that method, and in this we will write a print statement. Let us remove this, it is not required. Just to, we want to see about super and constructor only, right? So we can write a print statement over here, and let us print uh, from parent constructors we will print the name that is passed. Okay, so I'll prepare a f string and just write from parent or parents constructor and put this and just write self dot name. Okay, so whenever we create an object for parent, it will and pass a value for name. Whenever we are creating object, that will be passed to the name, and that instance variable be assigned with the provided name, and this print line will be executed. And now let us, we already created a child. Instead of child one, just put as child, and it is inheriting from parent, and it also has a constructor in it. Okay, and we have self name as well as one more variable we will take in the child constructor, and here we will call this line because, and you can see this is automatically added. Why? Because we are using inheritance and it knows to use this line, so we are calling the parent classes constructor, so that that will be accessed from child class object as well. Whenever we create something, it will get the name also. And here we have one more instance variable age, right? So self dot age equal to age, and let us write a print statement similar to the above print, and here we just print the age of the age which we provided. So, and we will write as from child's constructor, and we will print self dot age. Okay, so now let us create an object for child and see. You will get both printed. C equal to child of, we will be providing two variables over here, maybe Raja, comma 38. So I'm not going to call anything because we already have print statements in the constructor itself, right? So if we run this code, we can see from parents constructor we got Raja, as well as from child's constructor we got 38. So how to refer the constructor of parent from child class means using the super keyword. Okay, so this is one thing, and one more important thing we need to discuss when we are talking about inheritance is the diamond problem. Usually we say, if you are aware of C sharp or Java programming, those does not support multiple inheritance with classes directly, because there will be an ambiguity in calling the methods when classes have multiple parents. So we will see some example, but that is allowed in Python, and we will see how Python allows that and why Python allows that also. So for that, let us take one example. Maybe we can take multiple inheritance we have already written, right? Or no problem, let us create another class A. Okay, so in this, just define a function or a method show, and inside this just print class A. Got it? Because this is class A, and that's all. Now define another class B and inherit this from A, and define another function with the same name show. Okay, and here instead of that we will simply write class B, and let us create another class again C, which is also inherits from A only, and we write the function show here, and inside we will write the message C, class C. And now create a class D and inherit from B and C both. So now we have the concept of hybrid inheritance over here, and in this we don't need to do anything, we can just pass. Okay, now if we create an object for D, okay, and sorry, equal to D, and if we try to access d.show, now in other programming languages there will be a problem. See, we are calling d.show and d has two parents, and it it will be confused what version of show should be called, because d has access to show from C as well as B, and even A has show. Got it? So all are having their version of methods. Actually, we will discuss one topic, overriding, in future classes, so that it will be little easier to understand this more. But now let us consider these classes have same method and they have their own version of implementation. And now D may confuse, I mean, especially in Java or C Sharp, D confuse what version of show to be taken. Either it is from B or C, because it has access to both and even A also, and how many number of times I need to call that. So it will be facing some ambiguity, right? That is why Java and C Sharp is not allowing multiple inheritance with classes, but Python is allowing that. How means Python actually resolves this diamond problem using a mechanism called method resolution order. Okay, so you just remember the term MRO, means method resolution order. So it just checks for the method like this. So it checks for the methods in D. If it has show in D, it picks that. Otherwise, it picks from B. Because it is inheriting from multiple classes, it goes in this order. This is how it resolves the method. So it checks in B. If it finds some method in B, it gets that definition, that version. If it does not find, it goes to C. Even if it does not find in C also, then it will check the parents of B and C. That is how the method will be resolved. Now, as we discuss the method resolution order, we can guess what version of show will be executed. So it will check in D. We don't have show in D. So it goes for the first class over here, B. So B's version has B has show method. So B's version should be called. Let us see that. See, class B is executed. If you reverse this by B and C, save this, and if you execute this again, you will see C's version is printed. Why? Because it is the first class mentioned in the inheritance list. So that is how the methods are resolved. Okay, and this is actually called the method resolution order. And Python follows one more term you need to remember, C3 linearization. That is actually called method resolution order to determine the method execution order. Got it? And because of this method resolution order, Python is actually allowing multiple inheritance. So that's all about inheritance in Python. Just to conclude, we just discussed what exactly inheritance is. So inheritance is one of the key features provided by object-oriented programming concepts, and it promotes code reusability and efficiency. And in this video, we covered all the types of inheritance. Those are single inheritance, multiple inheritance, multi-level inheritance, hierarchical inheritance, and hybrid inheritance. And we have also seen the constructors and superconstructors. Okay, and we have seen about MRO, which is nothing but the method resolution order. Got it? So in the next video, let us see about one more object-oriented programming concept. Thank you for watching, and please don't forget to like and subscribe.